Welcome, 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 welcome. More miserables. Congratulations on the show. Welcome all. I hope everybody is doing fantastic. I welcome you all to Weird Science Wednesday. Yeah. Talking about some fun stuff today. Magnetism. And if you're all just tuning in, and if you haven't hit that favorite button, please do so. Thank you for the favorite. Thank you for the favorites. I am Mike F. Bell, and this is Weird Science. Hey, welcome, welcome, welcome. How is everybody? Good to see you all, and nice that you turned out and are tuning in. I'm Mike F. Bell, and this is Weird Science Wednesday. This is another launch. This is the Blue Origin. Blue Origin, if you're not familiar, is the program that Amazon owns Blue Origin, and they are testing their Blue Origin capsule. So I'm gonna show you what happened with their last one. It was actually pretty fantastic. So here we go.
4. Command engine start. 2, 1. Ignition.
There we go. Throttling up. Look at that. Look at that authority that takes off with. It's very awesome. Like, here they go.
Look at her. Go. Mission Control has confirmed new.
It's like it straight up looks fake.
On her way to space,
but it's real.
One in the West Texas desert with Mannequin Skywalker on board.
Mannequin Skywalker is their little mannequin guy.
The vehicle are going to help the vehicle do its
Mannequin
roll maneuver.
Skywalker.
The booster is going to be rolling at about 2 to 3 degrees per second, which equates to a full rotation of the vehicle every 2 to 3 minutes.
Yeah, this is pretty cool. How this works is like it's constantly rotating like slowly around, so everybody gets to see.
All right, coming up here on Max Q, maximum dynamic pressure on the rockets. The toughest portion of the flight for the rocket
is Max Q.
Confirmed Max Q.
Max Q is the maximum aerodynamic pressure, and that's the fastest speed at the most thick part of the atmosphere. So it's where they're experiencing the maximum loads. Yeah, I imagine the inertia on those things would be intense.
As she climbs up towards space, in the bottom left corner is the altimeter, noted in feet above ground level, although you may have noticed upon
and you can see like it's
above mean sea level,
very high,
of our West Texas launch site.
And this is capable of getting into orbit. What's up, Vampy? And Nirvana, a pleasure to see you all.
And they're starting to feel those G's, around 3.5 G's on the way up to space.
3.5 G's, not too bad if you're laying on your back.
But in that horizontal position of the seats, definitely is a much more comfortable ride.
That's true. Because you figure you're going to have to experience some G-forces to overcome gravity. It's like if you're going 1G, you're just the same as gravity.
We're going to shut off the BE3 engine.
It's interesting.
MECO is confirmed.
MECO, that's main engine cutoff. That happens, and then stage separation,
Booster
followed
and the
by
capsule are continuing
second
at
engine
their
start.
combined ascent to space as you watch the altitude continue to speed is dropping, of course.
So the first booster stage comes back down, because that's only to get it up. Because when you actually launch into orbit,
you start to see the two craft in the screen.
Bill Nye got nothing. Agreed. Thank you so much.
Thank
No,
you again, everybody, for
I
joining
am
us
not
today.
Bill
New
Nye.
Shepard's 14th
I am
mission to
Mike
space.
Bell. Make sure you
The main
favor
launch
me
for this
and
rocket
smash that
so
favorite
far,
button.
everything
Hit those
appears
hearts.
phenomenal.
Send those diamonds. I love you guys. You're awesome.
Separated right about now is when, if you were an astronaut in there, that's when you'd be able to float around, gaze out of those huge, gorgeous windows.
And this is going to happen in our
Maybe
lifetime.
you can do a
This
somersault
is,
or two. I know I would certainly do that.
can you imagine like floating around in space?
And as we've noted in previous flights, if you
That'd be
follow
epic.
the speed on the top right corner, as soon as that speed hits 0, that's when you know that the rocket.
Let's all get high on education,
the
y'all.
highest point
I agree. Education is the best thing, and it's good to learn. I always try to learn every single day. So what's going on is they have that second stage that's going to be circularizing the orbit.
Go, it's hit 0,
I am.
and now they are heading back home.
I have my master's in structural engineering, and I've done all kinds of work with
coming up here shortly.
everything. Yeah, Sean, I know that. Sean, you are the spectrometrist.
Line of space, and there it is, 350,827
Yeah, whatever.
feet.
I'm not going to tip it. Analytical spectrometry.
Level, so that's,
Spectrometry.
that is excellent. A great flight, well over the Kármán line.
Very cool. The Kármán line is at 100 kilometers. 100 kilometers above the surface of the Earth is what qualifies as space. So once you cross the 100-kilometer line, you are an astronaut.
But now we're making sure everybody gets the perfect view.
Mass spectrometry. Spectrometry.
All right, the two craft are heading back home now. The booster is going to beat the capsule back home. Obviously, it's more aerodynamically shaped.
Exactly.
And so it's going to come down first. Right about now, in the next 10 to 15 seconds or so, this is when we expect the rocket to hit atmospheric pierce point. That means
and that's where it gets get back into the atmosphere, and the aerodynamic control surfaces take back over.
Aerodynamic surfaces to push, and that will help guide the rocket back to its landing pad again, 2 miles north of where it's taken off from.
It's like what are they down to? I think they're down to like rocket riser 100,000.
Those fins are at the forward section, the top section.
How was everybody today?
In the ring fin.
It's like if you're just tuning in, this is Weird Science, and I'm Mike F. Bell. We're watching Blue Origins. That's Amazon's space system. They are testing their rocket, and we're checking it out. Hey, Monday.
And this booster is
Jamil,
right
how are you?
It is at its maximum return velocity. Is
Maximum return velocity. So Mach 4. That you're going to hear a crack coming in once this all goes through. You're going to hear like.
So we're looking now for the drag brakes to deploy. As soon as those deploy, you'll see the speed come down.
How are you, Monday?
You see that in the top right corner there.
It's dating and learning. It's science show with me, Mike F. Bell.
DE3 engine to restart.
So if you're new to this,
the landing gear will deploy.
I hope you all have questions.
Right, nice soft touchdown. There are the drag brakes.
Yep. Drag brakes, see them up at the top. Those are like the fins that extend. And what happens is, there you go.
Engine restart.
Boom.
Landing gear deployed.
Bam, look at that. Perfect.
Touchdown. Welcome back, New Shepard.
Woohoo! New Shepard
Here
is
our team
awesome.
back here at
And
headquarters enjoying
these
this
are
moment
super
with
deep,
this
but-
rocket. What a day. Did a nice little maneuver there to bring it back to the center of the pad, but that is
All right. Well,
completely
enough of
along the
that.
path.
I wanted
That
to
never gets old. That's the
just
type of stuff
make
that
sure
makes
that
my
we have a
rocket
plan
launch
today,
really
and
super
this is what we're doing. It's just an introduction, and then, of course, this right now. We're going on to our experiments, and they're all about magnetism.
Incredible. Kudos to our whole team for adding yet another rocket to our fleet. Wow. Okay. Well, the show is not over.
That's right.
We still
There we
are
go.
waiting here for the crew capsule to come back.
And
As noted, first the drogue chutes will deploy. Those are like the guide parachutes.
okay. Sorry about that. Now, welcome all. Welcome. This is Weird Science Wednesday. I'm Mike. And you know what? We are talking about magnetism today. So, some fun stuff to talk about when it comes to magnets. Everybody knows what magnets are all about. You played with them before. You have seen various magnets. And the thing about magnets is, you're a magnet. Yes, opposites attract. So maybe it's possibly, ferromagnetic element iron, nickel, and cobalt. Iron, nickel, cobalt are what make up the basic magnet. But with these, they're actually a neodymium iron borite. So these magnets, they're a little different. It's they're stronger. They're a lot more powerful than what you would originally see in a normal magnet. Magnets are made differently than other materials. How they're made is kind of weird compared to other stuff. Let me show you. Here we go. So down here, I got the manufacturer of magnets. Basically, what's going on is they have a powder form, and this powder they put into a mold, and then they just heat it up, and that heat makes it fuse together. And then that's under a magnetic field while they do that, and that magnetic field gets trapped in the cooling off of this magnet. So everything is responsible for, like, the magnet. Is this Bill Nye? Yes. No. Maybe so, except better. I am Mike F. Bell, and this is Weird Science. Magnets. So they stick together, right? And magnets are made with like a sand, and they fuse them together. And what's weird is you can actually destroy a magnet pretty easily. So if you take this magnet and drop it on the floor, because oh well, it's not a big deal. Because oh well, oops. Ah! It's like shit's going down. Not a big deal. Current flows, yes. Current flows through, and mostly electromagnets. So an electromagnet is a little bit different than a permanent magnet, because a permanent magnet is something like this. It's here. Let's go to the first. Okay, take that one off, and hopefully we can see here. I got okay, so I got some magnets, and then I got a magnet suspended from a pendulum. And then you can put the magnets down here and actually make them repel or attract one another. So like this, for instance, it's attraction. So That's pretty neat. Like it's neat watching the orbital dynamics kind of. It's very similar to how gravity works. Electricity and magnetism are similar to gravity in the calculations, at least. So that's attractive magnet. And then here, a repulsive magnet. And then, oops, I have to go upside down. There we go, that's repulsive. So, like with various arrangements, you could make the pattern pretty neat. And like this all goes into orbit. So this is pretty fantastic. One of the neat things about this whole system is everything is magnetic. And you could actually make magnets. So what I'm going to show you next is an electromagnet. So I've got a, hopefully you can all see everything I'm doing. Okay, I've got a 9-volt battery, and then I'm gonna attach that to there, and then the other side, I have, if you look down in that bottom box, you'll see that I have wire wrapped around an iron core. That's how you make an electromagnet, because through the wire, what happens is you have an electric charge moving through there, a current. That current creates a magnetic field. So if you have a current, it's called the right-hand rule, is the easy way to think about this. Thank you so much. Woohoo! But anyway, the thing about that is the right-hand rule. So take your right hand, consider your thumb to be the direction of the wire, and then that current is traveling around that wire, through that wire, right? And then your fingers are the electric current. So that electric current is circling. So what I've done here is you take this and you coil wire around a iron core and then connect the battery, and then I should have, yeah, it's weakly magnetic, but hopefully you can see that. And then as soon as I let off the current, watch it drop. See? It drops right off. Yes. So that's pretty neat. Like magnets are pretty amazing. Like we have everyday applications of magnets. Well, headphones are a big one. Speakers. Headphones and speakers, they need magnets in order to function. It's like it's the pulsing of that magnetic field. Thank you all so much for joining. This is Weird Science Wednesday, and I am your host, Mike F. Bell. We're talking about magnetism today. So we have electromagnets and we have permanent magnets. Permanent magnets are based on just like the composition of the material. The electromagnets, they are based on the current that's flowing through that wire that's wrapped around. So electromagnets are very powerful. You could have some huge electromagnets. For instance, in scrap yards, they use these big cranes with giant electromagnets to lift up all the scrap metal. It's a fantastic thing to witness. Yes, I am using neodymium magnets. They're neodymium iron borite. It's the same. It's a rare earth magnet. That's what they're referred to as rare earths because neodymium is a rare earth element. Um, Rare earths are actually super important. If you have magnets or if you have old electronics, it's very important that you recycle all that. Don't just throw it away because there's a lot of rare earth elements that are necessary to the manufacture of new technology that you don't want to just throw away. So, welcome all to the show. I am Mike Bell, and this is Weird Science Wednesday. We're just talking about magnetism and different types of magnets. I just did that experiment for you guys and showed you the electromagnet. And then, of course, we have some basic neodymium magnets. Yeah, in a small shape. Neodymiums are very strong. And with neodymium magnets, a lot of the components in generators or in wind turbines are rare earth elements like neodymium because they use neodymium to make the magnets. You can create a magnet for cars. Do they make them down? There's little tiny magnets. Look at this. I mean, the thing about magnets too is I have little. I can't even see them, but yeah. The thing about magnets is there is no such thing as a magnetic monopole. So what that means is there's always a north and a south pole. Always an north and a south. So if I was to take this magnet and hit it with a hammer. Okay, so let's take a look at this one. So, whoops. There we go. Watch that one. Damn it. Probably not a good idea. I need a better table. But when you break a magnet, it just breaks into pieces that you can't get back together. And this leads me to another neat thing about magnetism. So here we have iron rod, a simple iron rod. Did you know that you can make a magnet just by aligning the iron rod in the magnetic field and striking it with a hammer? Yeah, I didn't believe it either until I did it myself. So you take this, you need a compass as well. So have a compass. Okay, so you line it up with the magnetic north, which is this way. Trust me on that one. And then what you do is you take the rod and tilt it a little bit like that, and then you strike the end of the hammer. Okay. And look at that. It's now magnetized, slightly magnetized, very slightly, but it is magnetized nonetheless. So that's a pretty neat little thing. Like magnetism exists. It's all because of the molecules and the atoms that are vibrating, and you just get that magnetic electrical charge. It's all a neat thing. So, next, thank you all for joining me. I am Mike Bell, and this is Weird Science Wednesday. Thank you all for tuning in. We're talking about magnetism and different types of magnets and all kinds of cool stuff like making a magnet out of a metal rod and just smacking it with a hammer, or making an electromagnet. An electromagnet is just another. Electromagnet is just very attractive. There is lots of magnetic jokes that we can make today for sure, and I'm not going to go into those. I'm so bad at doing dad jokes, so I don't want to do that. Okay, so let's see. Let's go on to the next thing. Ba-dum-bum. Okay, so this is the next one. So the thing with magnets is they interact with copper. Everything is magnetic. So like iron and whatnot, iron and all the different, magnetic. Oh, and this one to show you this too, because this is a neat little trick. So hopefully you can see. Okay. Whoop. That's a magnet. And watch. Magnets are only under kinetic energy. Copper can create electrons. Exactly. So that's a neat thing. And one thing that I'm going to show you real quick is the Curie temperature. So I'm going to actually destroy this magnet just by heating it. So watch closely. And that is the end of that magnet. No. It's no longer magnetic. It is very hot. So I'm going to drop that because it's about to handle. So here we go. That's the magnetic goodness that's going on. So, yeah. Nobody worry. It's like, this is perfectly normal. So what we have is, I want to show you the next thing, the interaction of copper and okay, so I got some copper pipes, and now we're going to see how cool this is that this interacts with magnets. So if I was to take a stack of magnets, like I have here, and okay, so here, if I was to drop these two magnets, hopefully you can see. So if I just drop this from this height, you heard that, right? Just like that. That's just dropping it in there. Now watch what happens when I drop it through this magnet or through this copper tube. See, it goes a lot slower. And actually, I have a really long piece of copper tube here. It's 10 foot, so I'm not sure how I'm going to get this in the frame, but you will get the idea. I'm going to drop this and then stand it up. Still going. Still going, and drop. Just dropped out of there. That's pretty incredible because that is because of the inductance that's arising in the material because of the magnetic field. And that magnetic field is all because of the moving electrons. So that is hopefully pretty interesting. I hope you like the fact that magnets are like everywhere, and if we didn't have magnets, we wouldn't be able to do a lot. So next, what I'm going to show you after I take a drink of water the Earth itself is a giant magnet, north and south poles. That's why magnets have a north and a south pole, just like the Earth. It's and if you're just tuning in, this is Weird Science. I'm Mike F. Bell, and we're looking at magnetism today. We are living on a magnet, exactly. Exactly. That's very, very cool. Like, I thought the neat thing was being able to hit a iron rod with a hammer and magnetize it. Like, that is just a weird concept, right? Yeah, if you take an iron rod and you align it in the Earth's magnetic field. So you need a compass needle, or compass, whatever. And then you hold it in the same line, and then you actually take it and you tip it, and then hit the end of the hammer, or hit the end of the rod with a hammer. It will be, you hit it a couple times, and it'll become magnetized. And the reason that is because the Earth's magnetic field is actually powerful enough to magnetize the steel, the iron. Because what's happening is those atoms are getting bumped and vibrated every time you hammer it. So they're actually able to jiggle and align with the Earth's magnetic field. So that's why you have a weak magnetic field that arises from that. And thank you all so much for the favorites. I'm Mike F. Bell. This is Weird Science. So, how many of you have heard of a homopolar motor? A homopolar motor. It's like, that's a mouthful. All right, so let's see. Look at this. Okay, so basically what a homopolar motor is, no, not a bipolar, homopolar. It's not a gay magnet either. Despite what it sounds like, homo means one. Homopolar motor, yes. So what we're going to do is take a battery and a neodymium magnet and also a little bit of wire, copper wire, and hopefully get a magnetic current or a little motor that runs because of the magnetism. What's up, Cuddy? Laughing so hard. Good. Well, I hope you're having a great time. King me. Thank you. Paulie Class Clown, 1994, exactly. So here we go. Let's see if we could build this homopolar motor. So I got let's see. Hopefully this and this. We want to. And I should turn off this. We don't need that. Whoops, wrong one. There we go. All right, so if you can see what I'm doing here, hopefully. So I've got a nail or a screw. Got too much stuff going on. Can you see? Hopefully it's just a nail or a screw. So saying a nail, it's not a nail, it's a screw. So anyway, I put a magnet on the bottom of this nail or a screw. It's like, I'll get this right eventually. It's a screw, not a nail. And then that just magnets onto the bottom. And then I just gotta these are all and see what I'm doing. Okay. So now I'm going to connect this battery and the magnet and everything holds it together, and then hopefully the screw should rotate. Okay, it's starting to spark. That's a good sign. Do you see it moving? It's definitely rotating. I can't get a good connection, but as soon as I get a good connection, you can get this thing spinning pretty rapidly, actually. I had it go in a quick pace before, so just got to manipulate it a little bit and get it to work. Whoops. Not like that. Okay. It's rotating. I just can't get it to go fast. Well, you get the idea. It works. It does actually, in fact, work. Yeah. Yeah, thank you all so much. If you're just joining me, we're here at Weird Science. I'm Mike F. Bell, and we're just looking at some magnets and properties of magnetism. Cool stuff. So we took a look at the two different types of magnets. There's the electromagnets, and there is also a permanent magnet. So permanent magnets are similar to, they are like the neodymium magnets. And neodymium magnets, if you remember, are all permanent magnets, and permanent magnets are dependent on temperature. And that Curie temperature, if it's exceeded, like before, when I heated that magnet up with the torch, it stopped being a magnet. These are rare earth magnets, yes. Neo is the one. Oh, wait, that's a character in the movie. Yes. Neodymium magnets. Neodymium iron borite. So these are the magnets that are the most powerful permanent magnets that currently exist. These are N52 grade magnets, so they're the strongest type. They're very fragile, however, so if you drop them on the tiled floor, they'll crack into pieces. And once a magnet cracks into pieces, it is gone forever. That is because there's no such thing as a magnetic dipole. A Or, I mean, there's no such thing as a magnetic monopole. There's only magnetic dipoles. Yeah, so, and temporary magnetics are man-made, correct. Here, well, let me show you this, Cuddy. Here we go. This right here is an electromagnet that I built. It's just a little iron core. And there is a length of wire that I've wrapped around it. And then once I connect this, it actually becomes magnetic. And to show you that, I have a piece of iron or metal. Hold on. It's easier to pick it up from here, but it's electromagnet, and just because it's not getting good contact. So it's definitely interacting with us, but yeah, oh well. Not a big deal. Neodymium magnet, yep. Temporary on refrigeration. No, actually, once a magnet becomes heated above its Curie point, it will not become a magnet again until it goes through the original remagnetization process. And if you remember, that's that powder that they put into molds and heat it and then cool it under a strong magnetic field. Yeah. Future applications for that is because they exceed their Curie temperature. The Curie temperature is the point at which you exceed that temperature and it loses its magnetic field. And it won't be able to gain its magnetic field back by like cooling it down or anything like that. So once the magnetic field is gone, it's gone. You actually have to, what actually happens, everything starts to vibrate. It's kind of similar to how I took that steel bar or the iron bar and smacked it with a hammer in the direction of the magnetic field to magnetize it. That's similar to what's going on there, except this is demagnetizing it. It's causing the interactions without actually getting into the hardcore science. And if you're just joining me now, this is Weird Science. I'm Mike F. Bell, and we're talking about magnetism. Excuse me. I need to find my water. But the neat thing too was talked about magnets are used for trains. They are. Ferromagnetism is pretty simple, I feel like. Is ferrite considered a magnetic compound? Yes. Iron, cobalt, and nickel, and also neodymium. There's other alloys that they make that are capable of being magnetized. So not everything can be magnetized. But it's neat because trains actually use it. I don't know if you've been to what is it, Islands of Adventure or Adventure Island or something like that out in Orlando. They have a Hulk ride, the magnetic propulsion on the Hulk. So it actually uses a linear electric motor, and that propels the roller coaster forward. And I think it's pretty impressive because that is that's like the launching with electromagnetic force is something that is very powerful. Trains use it. Trains use electromagnetic force. And your question. And the Earth has the strongest magnetic. Yes. Well, yeah, strongest. But I mean, like for instance, locally, if I was to take my magnet and I don't know if you can see this. You see, like, this camera angles are not that good. Crap. Yeah, so the magnetic field gets affected by the material. Like locally, it gets affected by other magnets, but as soon as I take this away, the Earth's magnetic field takes over. So that shows just how strong the magnetic field is. And what is this theory of a pole shift from north to south to cause it? Yeah. So right now, our Earth is a magnet, a giant magnet, and we have a North Pole and a South Pole. And that magnetic field comes out and goes around the planet and actually protects us from the harmful effects of solar radiation. Solar radiation is actually magnetized, so every once in a while you have a coronal mass ejection, a CME, and that is highly magnetized electrical. It's like an electrical pulse, and it takes stuff out. It can take out power grids, satellites, depending on how bad the EMP is. But luckily, we have our magnetic field. And hey, Al, thank you for joining us. Thank you for joining me. I am Mike Bell, and this is Weird Science. So the Earth's magnetic field, what's going on is it's protecting us. It's actually like deflecting all the sun's radiation, or a good majority of it. And it makes us Monday. There you go. So what happens? Hey, what's going on? Louis Vuitton, Kendall Vuitton. And what's happening? That electromagnetic radiation comes in. It gets deflected because of our magnetic field. And it's a good thing because Mars lost that protection that they had, and the sun was able to strip the atmosphere off the surface of the planet. So theoretically, yeah, they happen. Yeah, they happen periodically. They've, if you look at the like ice from the poles, or even like clay pottery from different times, you'll see that the magnetic field was different. So it's okay because it flips from time to time, but it's that period where they go from north to south, south to north, where it weakens. And that weakening is where things could go wrong. You could have a lot of problems with it. But I like to think that by the time magnetic shift happens, which it probably is in the midst of happening, we'll have the ability to strengthen our own magnetic field with our technology. I mean, our advances in magnetism and like electromagnets, even, it just all. So the Earth's magnetic field keep on the no. It's actually it's gravity that keeps on its axis. Yeah, for sure. Like it is gravity that keeps it up, but like that magnetic field, it's super, super important to make sure that cosmic radiation and solar radiation doesn't just like blast us and strip our atmosphere off, because it wouldn't take very long of not having a magnetic field for that to happen. If we lose magnetic field, we would be fucked. Excuse my language, but yes, it would be bad. What happens is the solar radiation would hit the planet, and what would happen is that radiation would strip off the atmosphere. So you'd have atmosphere that's being stripped off the planet and launched into space. It would be bad. It'd be really bad. We'd get fried. Yeah, you probably wouldn't. And the likelihood is it's not going to happen during any of our lifetimes, so it's all good. Is there other ways to get in touch another way, like Facebook? There is. I have an Instagram page. It's Mike F. Bell. I encourage you all to follow me there. I respond to my DMs, and if you guys have any questions or future suggestions for shows, I really hope that you could hit me up on there. So does the magnetic field play a part in how the Earth rotates? No, that actually is just how things were set originally, like how the collisions happen. Some planets rotate backwards from the other way. It really just depends. Because like that experiment before that I was doing with the this and the orbits, it's kind of like this. Well, not like that, but yeah. So does the magnet. Excuse me. It's like I've been talking a lot. And if you're all just joining, we're here and we're doing some weird science. I am Mike F. Bell, and you know what? I hope you are enjoying learning about magnetism. We've covered a few things about different types of magnets and electromagnets. We've covered homopolar motors. We've covered the interaction of copper. We've covered the Curie temperature and how the change in temperature will destroy a magnetic field. But I thank you all so much for tuning out, or for tuning in and turning out. Interdimensional time portals, who knows? Anything's possible, right? Arthur C. Clarke said it best. Any sufficiently advanced technology is indistinguishable from magic. So things seem crazy when you first learn about them, but once you understand the science behind it, it makes a lot more sense. And that's what I hope to do, is take the science and break it down and make it understandable. And thank you all so much if you are just joining me. We're coming down to the end of Weird Science. That is, it is. It totally is a good quote. And Arthur C. Clarke was a very inspirational man. He was a visionary. Oops. Okay. So we have I showed you the homopolar motor. Wasn't the easiest thing to get going, but I might be able to get it rolling. It all depends. And thank you all so much. Thank you, Jules. Jules, thank you for stopping in. It's like we're taking a look at magnetism, and we're doing some fun stuff here. I am making a homopolar motor right here. So it's basically, you can see that. And then I connect this. There's a battery on the bottom of it. It's a screw. Well, first I need to connect it. Okay, it's going. I don't know if you can see it rotating, but it's actually going. Well, I am. I'm showcased. I am featured. I am in the featured box. I have a featured show on here, so if you're just tuning in, I'm Mike F. Bell, and this is Weird Science. I use earth magnets daily for testing precious metals I sell. That's cool. That's good. It's like not everything is magnetic, right? It's rare earth metals. They show the iron content right away. So iron is magnetic, but gold and silver, they're not. Science Ricks! Like Rick and Morty. We have a telescope only. We are seeing Andromeda. Yes. That's awesome. But I think it's pretty cool that you can just make a motor out of just a AA battery, a screw with a little neodymium magnet popped on the bottom, and then you just put it on there, like put it onto the negative terminal like that, and connect. So you got one. There we go. Yeah, it's rotating. It's hard to see that. So they use supermagnets in the Hadron Collider, supposedly 100,000 times the Earth's magnetic. I think it's titanium. Titanium is non-magnetic. Excuse me. Yeah, titanium is non-magnetic. That's why they actually use it in medical procedures. I actually have a titanium plate in my head. It's like I've gone through 9 brain surgeries, 30 treatments of radiation, and I do have a titanium plate in my head. So I know that it's definitely non-magnetic, because otherwise I would not be able to get an MRI. And if you're just joining me, I'm Mike F. Bell. This is Weird Science. We're getting down to the end of the hour, and I just wanted to thank you all for coming and viewing. I really appreciate this. I totally appreciate every favorite. It's like, thank you for the favorite. First time. This is awesome. Well, thank you so much. I really do appreciate it. I do this every Wednesday at 3 p.m. Eastern, 12 p.m. Pacific time. Weird Science. It's a Meet Me featured show, and I talk about different topics every week. So this week we talked about magnetism. So I love you, Mike Ramses. Hello here. Thank you. Yeah, I actually have some ideas for gravity segment. So one of these future weeks, I will be doing a segment on gravity, and I have some cool ideas in mind. But if you have any ideas or if there are experiments that you would like to see, I encourage you to follow me on Instagram at MikeFL, same as my username, and send me some DMs, ask me some questions, send some ideas for experiments that you might want to see, and I'll see about doing them. Yeah, there's got to be some kind of something, right? I don't know. Yeah, everybody just go ahead and slide into my DMs, please, and ask some questions. But anyway, it looks like I am done with my hour. So, thank you all so much for coming out. You guys rock. Thank you so much for the favorites. I really, really do appreciate favorites. It means a lot, like, because I can send out blasts and I can let you all know that I'm going live. So make sure you hit that favorite button. If you do one thing, hit that favorite button. Thank you for the favorite. Thank you for the favorite. Thank you for the favorite. And it's like, I will see you all next week at 3 p.m. Eastern, 12 p.m. Pacific time. This has been Weird Science, as